The next thing we want to think about is how do we take the derivative of functions that are not polynomials, like x to the n? Well, there are a few special cases where this could happen. So one case is a trig function, right? Like sine of x. You can't just use the power rule and bring down the exponent. It has to be different. Now, there is a proof of this derivative, but it's not really that important for you to understand for this class. So I'll link a Khan Academy video that explains this in more depth. But for now, all you need to know is that the derivative of sine of x equals cosine of x. The derivative of cosine of x is negative sine of x. And then the derivative of negative sine of x. Remember, we can treat the negative in front as like a -1 constant. So then you just take the derivative of sine, which is cosine, and then multiply by -1. So negative cosine x. Now another special derivative, which is a lot easier to memorize, is you remember that number e that equals like 2.7 something, right? Well, in calculus, it actually becomes important and you get to see where it comes from. So the property of that, what some consider the main property of e, is that the derivative of e to the x equals e to the x. It equals itself. So that's really important for some things where the derivative is proportional to itself, but we'll get to that more in Unit 7. So this is an important derivative. It'll come up a lot. And then the same rules, if it's multiplied by a constant, then you just take the derivative of e to the x and then times the constant. So if you have 2e to the x, derivative is still just 2e to the x. Same thing. And then the last special derivative is the derivative of ln of x, which is sort of related to e to the x. So the derivative of ln of x equals 1 over x. It's helpful just to memorize these. You don't really need to know where they come from for the exam, but if we look at what we have the derivative of sine equals cosine, derivative of cosine equals negative sine, derivative of e to the x equals e to the x, derivative of ln x equals 1 over x. Okay, there will be a couple more trig derivatives that we'll go over at the end, but these are the most important ones that you should definitely know. And then the next thing is another thing that we won't really show the full derivation for. I can link a video in the description that I think is helpful if you really want to understand where this comes from. But in reality, you're not really going to need to derive this on the test. You can just apply it.